Database mirroring. How many of you were at this talk last year? One. Good. How many of you are using database mirroring today? One. So my final slide is about lessons learned. I was hoping to have a few more. No matter. Database mirroring came about as a result of our realization that the cloud is not an ideal place for being individual. Let's say you live like this. This is what the typical on-site customer looks like from a technical standpoint. And here you can do pretty much whatever you want to do. Like if you have a hobby,
installing updates.
Restart required for updates. I'm not restarting. Let's say your hobby is to collect railway rolling stock. There are people who do that. Yeah. There are people who do that. I have a friend whose parents-in-law collect houses. So they have a big property and they have about 15 different buildings there that have been transplanted there from all over Norway. Or you can build one of these. And I mean, if you live in a place like that, probably no one is going to mind, depending on where it falls down. Now, when you move from on-site, on-premises to the cloud, it may perhaps feel a little bit like this. It's all the same. And it's perhaps not the best neighborhood. You are sharing resources with your neighbors. This is a real building, by the way. It was a very prestigious building made by a very famous architect. But I don't think he lived there.
North Korea or something?
No. Now, we try to imagine that the SuperOffice cloud is more like this, but it's still a cloud and it's still a question of sharing resources. And that brings us from the cloud to the ground to the nitty-gritty details of how is the database used in SuperOffice. Sales and service are essentially old-fashioned online transaction processing databases and applications. So that means the tables we have are quite well normalized. We don't repeat information from one table to another. If an address is shared between, that's a bad example because we never share addresses. But you get the idea. If a company has two addresses, it's not multiple address fields within the company record. That's normalized out into its own separate table. And these tables are indexed, and they are indexed for the kind of processing load that we expect from our own application. And that is typically a kind of load where you do a fairly simple search. And if you update something, it's an individual update of an individual record saying, now this particular address record, determined through its primary key, shall have new values for some fields. And we expect the database server to keep the keys and the popular indexes and rows cached. And everything's fast. There are no long-running transactions. If you use some of the SQL Server tools that allow you to peek at what is the server doing right now, most of the time you expect the answer to be nothing. It's not actually in the middle of processing 100 different queries. Even the online servers, if I do tell me what you're doing right now, I typically get a single-digit number of queries, like 5 or 8. And if I do the same query again, I get another 5 or 8, but they are different. The ones that I saw a moment ago finished, new ones are coming in. And that also means that locks are held for only very short times, which is good, because once you have too many locks, things start falling apart. Now, analytics and reporting are completely different. You tend to have big, long-running queries that span lots of tables. So you join everything. What you see in the company card comes from 13 different tables. And when you're doing reporting, you might actually be joining in all those 13 in one query. I wouldn't recommend it, but perhaps it's what you need to do. SQL Server has this wonderful property that if you have too many row locks, and I still think it's the hard limit of 5,000, then it says, I'm not doing this, I'm escalating this into a table lock. Bang! Which, by the way, is one of the reasons multi-tenant databases can be problematic, because tables become huge and you have much more of this block escalation. And so the usage patterns of reporting and transaction processing don't coexist well. And this is it's an old problem, it's well known. SQL Server does its best. It tries to not kill all the caches when it sees one of these flood wave queries coming by. But when you have the order of 1,000 customers sharing one server, it still doesn't work. And SuperOffice in the cloud has service level agreement. We are committed to providing a certain amount of uptime. And that is one of the reasons why we are very conservative with regards to running foreign code. As you well know, the answer is no. We're not running your C# code, we're certainly not running your C++ code, and we're not letting you into our database. Which then begs the question, how do you create a product for online that does reporting? I could, of course, tell you that, you have to use the net server service agents and you have to fetch your contact entities and then you can accumulate over them. And I see people laughing, and of course that would be just a total disaster. It's not built for doing massive queries like that. Doesn't work. Though in a later session today, I will be telling you about how you can actually do sort of these queries in that server using archive providers and the aggregation engine in there. So how do we fix this? Because we do think it's useful to have reporting tools also in online, which is enter the mirror, database mirroring. The original database in online, it contains all the updates all the time. That's the live database. It does contain potentially sensitive stuff, such as password hashes, lots of email addresses, other things. It runs in SuperOffice Online. It shares its SQL Server with other customers. It's managed by SuperOffice. You can't access it. What we are offering you is the chance to host a mirror. And the mirror is updated periodically, incrementally. We mirror most, but not all tables. There are a few tables where we say, you don't need that. These are not the tables you're looking for. So there's some information we're not passing on. Provisioning mirror databases is your problem, not mine. So you have to find a place to host them. That means you get to choose where to run them. You manage them. And since you own the place, you can do whatever you want with the mirror database. If you want to transform the data model into something else, fine. If you want to install stored procedures, if you want to create huge views, if you want to run big queries, excellent. Whatever you want, because it's your place. You own it. I'm just pushing data into it. Now, the mirror isn't shall we say, perfect. It's not an exact one-to-one image. And that means it's not a way to create a kind of travel database. Like I mirror it to my computer, then I'll go off and keep on using SuperOffice. It's strictly one way, and it's going to stay that way. It's also not an instant updated replica. There is a delay. When we designed database mirroring a year and a half ago, and that's an interesting story because Guttorm called me into his office and he said, Marek, we need to create a database mirror system. And I said, yes, do we? And he said, yes, and he explained why it was a good idea. Off you go and do it. And the first thing I did was go to Jens and tell him, Jens, we're going to make a database mirroring service and we're going to do periodic updates on all the customers' databases all over the world. And Jens said, no, you're not. Because there's a question of how much load does this create on our servers? So we started out very conservatively and we said, we'll guarantee that we are going to replicate the customer database, the live database, into the mirror at least once every day, once every 24 hours. And we asked around and asked people, if you're making a reporting analytic application, can you live with being this much out of date? And after some gnashing of teeth, people said, yeah, probably we can. And thus we said, we guarantee once per day. Now, in practice, we've ended up running it once every 10 minutes. And it's been doing that for a year. And nothing seems to be broken. But I'm not going to guarantee that. It depends totally on the number of customers, the turnover of the customers' databases, how much is being added, how much is being changed in the database, because it's the turnover that determines the load. How many apps are using it? How popular are these apps? I think that once an hour is probably something we will be able to guarantee. But for the time being, it's every 10 minutes. You can't use this to interfere in the user's workflow. You're sitting on a database mirror, which is somewhat out of date, and it gets periodically updated. You have no idea why the updates are happening. You cannot reach back to the customer's session. You can't use it to spy on passwords, session tickets, and such. You can't track the user preference table. Why not? User preference turns out to be one of the most heavily used tables that we have. The view state from the web client is stored there, and I know that a number of partners are using it as a dumping ground for stuff they need to store, especially when they need to store stuff per user. The structure of the user preference table is perfect for that. There are ways to get a hold of preference values through our ordinary service interface. That's fine, you can do that. And you don't necessarily get all changes, because if a record is changed multiple times and then the mirroring cycle runs, you get the final outcome. You do not get all the intermediate values that have been lost, overwritten over time. So every time we run a mirroring cycle, you get updated to what does the database look right now. You don't get all the history. We're offering this through the App Store, and it's packaged as, it's just a property of an app. So any app that you have in the App Store can have the checkbox data mirroring set. And if so, you need to supply an HTTPS URL that points to where you have your receiver, the place that we are going to call to push the data to. And that URL is different from the other URLs that are connected with your app. So this is an extra URL which is only used for the mirroring. And at that point, you have to implement the Windows Communication Foundation service with a certain interface, which is what I expect to find when I call and tell you, this is what happened. And we'll call it periodically. And we're doing it for free. And I asked Catherine just a few days ago, is this still true? And she said, yes, we're not charging you for this functionality. Of course, it creates cost for you because you need to host the mirror somewhere. You have to pay some database server licenses to someone to do it, but you don't have to pay us extra. The way it works, SQL Server has a functionality called change tracking, which you can look up on the web if you're interested, and it is exactly what it says, and it's exactly what we need. SQL Server simply maintains some internal tables where every time you change a record, SQL Server will determine the primary key of the row, and optionally it will keep the values. We're not using that. So we're just getting a flag saying at this point in time, this record in this table changed, or it was added, or it was deleted. And since it's SQL Server doing the change tracking, this works out of the box with all our tables, which our own travel transaction log does not. Travel transaction log is something that came from the CRM side. So changes to CRM tables are tracked in there. Changes to service tables are not. Changes to partner tables, maybe. Changes to service extra tables, again, not tracked in travel transaction log. But the SQL Server change tracking sees them all. It doesn't care. To SQL Server, table is a table. So that gives us comprehensive change tracking on all the tables that we need. It also gives us automatic cleanup. Our retention time is 7 days. If your mirror site is down for more than 7 days, we lose the ability to do an incremental update. We'll detect that, and we'll send a white message and reload everything. Periodically, we run the data mirroring agent, which performs a query against the SQL Server to get, for each mirrored table, what is the list of events, add, insert, delete, and the corresponding data for each event. That's a very efficient query. And that is what we send over to your site. And here, this call needs to be received, interpreted, and the corresponding tables updated there. I'm not going to do all the details. But this is one complete cycle. We start by querying the schema to see if something's changed in the schema. Do we have new tables? Do we have new fields? Has a table been deleted? We tell the mirroring site about that. And we get back how updated is the mirror. And how updated is expressed in the form of a log sequence number, which is SQL Server's transaction counter. It's a 64-bit global integer that just goes up, and it's simply a kind of high watermark. How far have we come? And note that that is something that's kept in the mirror. In the customer database in online, I have no idea how many mirrors are tracking this single customer, because it might be multiple apps for multiple partners. I don't care. I do continuous change tracking. When I talk to a mirror database, that database tells me how updated it is, how far in the log sequence number has it come. And then I turn around to the online database and say, tell me everything that's happened since that log sequence number. And then, what's this? Then we send the records for each table. And once we've done that, we do a final call, mirroring completed, which is your chance to do some post-processing, or at least note that one cycle completed, we're done. And that's it. Mirroring agent finishes execution. At some point, the scheduler will decide it's time to do it again. Now, security. You are taking on responsibility for keeping more or less the entire database of a customer safe. That's not a trivial matter. Customers' data have been given by the customer to us for processing. That means we have a data processing agreement with the customer. We need a similar agreement with you that delegates and transfers some of the responsibility to you, which means you have to fulfill all the same contractual obligations that we do. That means you have to ensure that you keep it safe. There's probably going to be some kind of auditing process to ensure that you're not falling asleep on the job after a couple of years. You will be subject to a security audit by Watchcom before you can say, I want to do mirroring. And we're trying to keep the communication itself reasonably secure. So we have this dance where at the start of each cycle, we call you sign our tokens with our private key. You have our public key, and the keys are different for the development environment, the staging environment, and the production environment. And you need to keep those separate as well. You provide an answer that you sign with your private key, which we don't know, but we do know your app's public key. That's part of your app registration. So we verify that all of this is correct. And that proves to us, to a very reasonable degree, that we are in fact talking to a site that hosts a mirror run by an app that has been properly registered, audited, and so on. And there's no one in the middle. And then we trust that endpoint for the remainder of that cycle. So we replicate all the tables, do all the schema changes, then we shut down, and we forget about you. And next time, it's the same all over again. As I said, some tables we just don't mirror. Some of them we took out from the mirroring list because they are irrelevant. Some because they are sensitive. Some because they are less relevant and have potentially a very high change volume, like the free text index contains and counter value in the Saint system contains potentially tens of millions of rows. They are regenerated every night. We don't want to spend huge amounts of communication and CPU resources moving all of that. It's not what we think you will need anyway. User preference, we already talked about. Binary objects, that's an interesting table because it contains a binary blob that could potentially be very large. We mirror that one, but we have a size limit on it. Anything bigger than 7 megabytes we skip. No complaints so far. This is where reality meets theory. Your mirroring site must be stateless, reentrant. So each mirroring cycle for each customer runs in a nice linear fashion, but multiple customers might be running simultaneously. So your site has to be able to handle that. One aspect that comes under lessons learned is some partners have multiple apps that use mirroring. And one customer might buy more than one of these apps. Now what? Mirroring is a property of an app. The mirroring URL is a property of an app. So the first answer is, okay, so you maintain one mirror per app. But that, of course, makes your cost go up. So you don't want to do that. So you use the same URL for multiple apps. Now we might actually run multiple mirroring cycles for the same customer for these different apps simultaneously. There's no lockout in our scheduler to detect this situation. And so far, the answer is, during the initial handshake, it is possible for you to tell us, abort this run. Don't mirror. That's during the authentication. You can answer back, I don't want this. And we're just, stop. We're not going to hold that against you. So after 10 minutes, we're going to try again.
So the strategy is just to ignore this run, and in the next go, you will be asked again.
Yes, for
it's
each
not
app.
Like you wait just 1 minute to see, are you ready now? Are you ready now? Okay,
no.
Sure.
You're just aborting, you're saying, don't do this, and we're saying, okay, fine, whatever. And then we'll just go on living our life as usual. So imagine you have 3 apps being synchronized for the same customer to the same target. In one case, app A might be the first one, and then the mirroring for B and C. You have to detect that you're in the middle of a run already and reply abort. And the next time, it actually might be app B that is synchronized first, because that just depends on what the scheduler is doing, what the servers are doing.
You could do that in your own way. You could say always A and not B and C ever. Then
well, I could, but I don't want to, because...
No, for you,
yeah.
But for us, we could say we only synchronize A.
Yes.
Then we know we have the 3 A, B, and C careful.
Absolutely, you could do that.
Except that if your customer has bought only B and C, then they will never be synchronized.
Oh, of course. But then,
You keep track of which ones you actually need.
Of course.
If you get one, that's enough.
Yeah.
And if
So-
they uninstall A, then I must, I'll look for B.
Yes. So somehow you have to keep track of this. And for those who have this problem, this solution has been good enough. So for the time being, we're leaving it at that.
I'm running.
Yeah. And a mirroring cycle has a well-defined beginning, that's the authentication call, and it has a well-defined end, that's the mirroring complete call. So it's fairly easy to set a flag and then reset it. The only time you get a start without an end is if something crashes on the way. We try to do the mirroring end anyway, but theoretically you could, crash us hard enough, or we could through our own bugs, to not get that. But so, like with any kind of lock, you need some kind of recovery mechanism if the lock gets stuck because you don't get the end of transaction, timeout or manual reset, something. Most of this I already said. Change tracking looks at the physical schema of the database, so it handles all the tables, whatever. And our experience shows that if you don't have any changes and the partner side doesn't have any big delays, it takes about 10 seconds to transfer the fact that nothing has happened, which is fairly reasonable. That includes all the overhead going over the internet and all the VCF stuff and such. Schema changes are propagated, so you get at the beginning of each mirroring cycle, we tell you the schema, what does it look like now? And we checksum that information and we keep one table, at least our implementation, I'll come back to that, our implementation of the mirroring system, client side, has one table where it keeps track of the schema checksum and the log sequence number for each mirrored table. So if all the checksums match, we know that no schema changes have occurred. That's obviously the normal case. If there are changes, then you need to update the mirror so that its schema matches the original, because everything you get in that cycle after that point is going to be according to the new schema. So when we do version upgrades from 7.5 to 8.0 or from 8.0 to 8.1, where there are database changes, this will all absorb that. That's nothing special about it. The mirror is going to change, so it looks like the original. And that's important because from more or less now on, we have our new way of describing the database and a new process, which means that theoretically we could be releasing database changes every 3 weeks in online. And I think at some point we're probably going to do that, because you can't actually contemplate creating any kind of meaningful feature without needing to store something in the database. And you can't do any meaningful change to a feature without needing a change in the database. So far we have avoided that, or we have been doing database changes very seldom. But that's not really because it's the ideal way of doing it. It's what we had to do because changing the database was so difficult. And from now on, it's going to be easy. And so the change rate is going to go up. And this system is already built to handle that. I knew this would happen. But there's one change coming which might be interesting to you. How many of you are familiar with the concept of a table number? And the fact that we use it in some relations, like in foreign key. We have table number, record ID relations. I call them text. Universal. Text. No, text is not the text owner type, owner ID. The owner ID is a record, but the text type is not a table number. It's an enum, because a table like project actually has two text records. You have the description and you have the paperclip. So that table and phone and address are the three remaining tables that have these funny enum things with bits and stuff in them. But everything else, like foreign key, really is a table number record ID pair. In a world where you have the database being changed every 3 weeks by different teams, SuperOffice releases something, partners do something, and in the future, customers do something. The order of changes can no longer be predicted, which means that the next batch of tables to come in from us comes either before or after the next batch of tables that you define, which means the table number becomes unpredictable. So within a database, the table number that a table gets assigned when it is created will stay that same number in that database for its lifetime. But in the neighboring database, where the table got created a month later, it might have a different table number, and it will keep that table number forever. So to interpret table numbers, you need to look in each database to see what they mean. And it's very easy because the table number field has been added together with the table name field to the sequence table. So it's very easy to look up. Those of you who don't care about universal relations can forget what I said. Those of you who do care, well, this is going to happen. It also makes the job of merging databases from different customers much more interesting. Because those databases might have different histories and so different table numbers. All the table numbers that we have up to now, the ones that you have in the 8.0 schema, those will stay the same forever. We're not going back and changing everything. That's not very much fun. So those will change, will stay, but new tables coming from now on will have unpredictable table numbers.
Yeah, but they stay the same.
But within a database, they stay the same. But if you're merging two databases that have different histories, table X, let's say we put in a new dashboard table. We're going to do that because we need a place to store the dashboard configuration. Now it's stored in the binary object table, and that's a mess. In some tables, depending on the amount of partner tables in them, the dashboard table might be table 457. In another, it might be 500. So that starts from January. That starts happening. And so if you merge two databases, if you have universal relations pointing to the dashboard tables, let's hope not, but if you do, they might have different table numbers in those two databases. As I said, merging becomes much more interesting. Perhaps someone can make a load of money by making a good merge tool. Client-side details. We have a service interface. It's a C# interface. It's also a WCF interface. You can make your own implementation. I'm perfectly happy with that. You are probably not, because it's quite a bit of work. So to make you even happier, we're giving you a complete working implementation for free. And as far as I know, that is what everyone is using today. It's very easy to use. You fire up Visual Studio, you create a web service project, you install the NuGet packages. You need to change a little bit of configuration information to tell the code where is the SQL server and what is your key. And you compile it and you deploy it and it works. And every time a new customer comes in, it tries to create a new database for that customer on the server you specified. And again, as far as I know, this is more or less what everyone is using. So this is actually production standard code, and it's being used every day. And it's a long time since anyone convinced me that they had found a bug in it. I don't have a bug bounty, but maybe I should. That code is SQL Server specific. And remember, I said we are using SQL Server change tracking. We can do that because online is SQL Server. We're never going to move online to Oracle. That's going to be over my dead body, and probably a lot of other dead bodies as well. Your mirror can be, in principle, on any database, but the client code you get from us works only on SQL Server. If you want to use some other database, then you need to override, re-implement at least the parts that interpret the schema and translate it to whatever data types your favorite database uses. So for the rest, I'm assuming you will be using our code. And if you think that's a bad idea, do tell me, preferably with beer. Now, the mirroring cycle, the whole mirroring system is based on the premise that SuperOffice is actually in charge of the whole process. There is no way you can say, please mirror now, or please don't mirror for 3 hours. Perhaps there should be, but you can't. And it's a one-way process, and it's all initiated from SuperOffice. So your service is sitting there, and it's just receiving the calls. What you can do is you can, of course, call any of the usual agents in the net server services. Since you're an approved app authorized into the customer's database, you have all the keys necessary to do that. So that's fine. But you cannot influence the mirroring scheduler. The client project looks like this. It's actually very small. You only have this service thing, and then the rest is in NuGet packages that install all you need. There is no net server in this stack, obviously, because the mirror database is not a database that net server is able to run on. That's intentional. We don't want you to think it's an updatable database. It's not an alternative client. It is a mirror meant for reporting and that kind of thing. To get started, you need to register your app in the App Store. You need to set the checkbox. You provide the URL. You generate the key pair. You keep the private key. You don't send it an email. I mean, the OC has a way to generate a public-private key pair, and then Margrethe can send you your private key. But you can hear that doesn't sound right. You should be doing your own key generation. You do need to install the SuperOffice public keys, because the code that we provide does the authentication and does the validation of the authentication call that comes from online. And that only works if the proper public keys have been installed on the server where this is running. So you need the SuperOffice Online root key, you need the correct environment key, this is a hierarchy, and you need the federated login key, that's the one we are using for the authentication dance. In Visual Studio, ASP.NET Web Project, install the packages, add a service. There are very few things that you need to do. You create a class that you inherit from the mirroring client implementation. You need to implement this method. The purpose of this method is to return a string, which is your application key. That's the key that you have in the operation center. You need to, if you trust us to do the validation and signing, you need to tell us the partner key, your private key for your app. Now, when I'm saying us, that is the code that you are running on your site. This key never gets posted over the network. That would be a gross breach of security. But it's used by our code to sign the reply of the authentication message. You can look inside our code and see that it doesn't do anything bad. And finally, resolve connection. That is perhaps the most interesting method of them, because that's where you have a customer context ID. That's the string that identifies the tenant. Typically it's cust12345, cust and the number. That's the customer number in online. That identifies the customer. That's the unique key that tells you which customer is this mirroring run being done for. And you need to somehow translate that into a connection string that my code can use when it logs on to the SQL server. And that connection string should log on to the correct server using some credentials that work, and it should also go to the correct database. So it needs to contain both a server clause, a database clause, and either username, password, or if you're using trusted security, AD login, then it just says trusted security. This method is also the one that should provision databases for new customers. So if there isn't, you come in cust12345, you've never seen that one before. At the latest, when resolve connection is called, you need to set up a database for that customer. Now, it shouldn't come as a call completely out of the blue, because the app has been authorized by the customer in the usual way through the App Store. So it means you have already had the calls that tell you that customer 12345 has in fact installed and authorized your app in the customer's database. So you could use that opportunity to provision the database, or you do it here. the example implementation you get from us actually does it here, because that gave us a chance of illustrating how to do it. It's fairly simple. You say create database. Well, first you ask the SQL Server, do you have a database called mirror12345? Yes? Fine. Build a connection string for that. If not, create the database, wait a while, and poll when it's ready, because the create database call returns too early. Guess how I find that out? And then build a connection string. And so this method returns the connection string, and our code running on your site does the rest. Now, we've provided some hooks because maybe there's something you need to do. onBeforeReplicate table gets called before we start replicating data for every table. So it gets called once per table, per replication cycle. And it includes as parameter schema change detected, which is a flag from our code saying the mirror schema is not the same as the source schema, so we're going to update it. If that means you need to do something, here's your opportunity to note that fact. There's also a client state. That's a string that you optionally put in your response to the authenticate call, the first call in a replication cycle. And what many people do is they take the result from resolve connection, the connection string, and they put that in the client state string, send it back to us, and we will include it in every call after that. So that's, you can use it for some kind of correlation identifier. You can cycle the whole connection string through it, so you don't have to do resolve every time. Whether you use it and what you use it for is up to you. The client state string is established during the authenticate response and then gets transmitted to you for every further call for that cycle, for that customer. OnWipe is called when we decide to wipe a table in the mirror. We might do that because we have lost the tracking information. That happens if you're down for more than our retention period, which is 7 days currently. But it could also be that some kind of disaster happened, or the customer restored from backup, and the log sequence number has gone backwards. Then you can't really do an incremental update. So we'll send a wipe, and then we'll send all the data as if it was new. On replication completed, that happens once at the end of the cycle. These hooks should be kept small because this is running synchronously. So our server makes a call to you saying replicate data for table X, goes into your hook, you do whatever you need to, it goes into our code which receives the data, then it returns to our server will then take the data for the next table. If you do heavy stuff in your hooks, all of this is going to slow down. And if that keeps happening, you will show up on our monitoring screens as, this app is spending a lot of time in the mirroring, more than anyone else. And Margrethe will be making inquiries, and you will be getting phone calls. So do the hooks to note, to leave flags, note that, oh, there was a schema change, or this table needs to be reindexed, or here's a new table, or whatever. And then for stuff that takes time, have your own background processes that are somehow triggered by this. You can also use the hooks to log things. And I have one piece of advice, or one piece of experience, which is that any error logging system will grow in complexity over time to the point that it introduces more errors than it logs. And I'm sure those of you who have been in the business for some time have made the same experience. You build these huge, wonderful logging systems that collect the information from all over. And they are extremely useful, but then you find out that you have a bug in the logging system, which causes the rest to crash. This has happened to us, and this has happened to other people. And when there is a crash in the code, the call stack ultimately comes back to us, and then it gets put into a mail automatically, again, which is sent to the technical contact registered on the app, which is you. And those call stacks tend to show that when there are problems, partner logging code is one of the places where that happens. So again, try to partition your code so that you send off stuff to be logged, but you're not dependent on the logging system actually working before you return to us. You need to be state-free and reinvent. Multiple synchronizations will run at the same time. If your app becomes popular, you have 100 customers, we have maybe 8 servers running the mirroring, you might be receiving 8 mirroring runs simultaneously. So all your code has to be written with that in mind. Each call stands completely on its own. Performance monitoring. We have our own monitoring tool which collects data in the code on our side. And it's simply a method call that says, this happened. We have now replicated table X for customer, Y for app ID, Z. And it took this much time. So our code in the online servers is logging all of this. I have included similar calls in the client code that we give to you. That monitoring information gets passed back to us, unless your firewall blocks it. If your firewall blocks it, nothing bad happens, except we don't get the information. So far, people have found that to be acceptable. And what we do is we count and we measure durations on the client side. I hope you think that's acceptable. We also get back the machine name. So that would be your machine name. And we end up with graphs like this, which tell us things like how long, when did the mirroring happen, how long did it take. This is how I can say that things take between 5 and 10 seconds, because I have lots of history that show me. And this is per customer, but it could have been aggregated per app or per a number of dimensions. We also track how much traffic was in each cycle. And it's aggregated per minute. So this was one replication for one customer that spanned a total of 4 minutes. It might have taken 3.5 minutes, but it spanned 4 minutes. And it transmitted a total of about 10 megabytes, 11. This is for a different customer, and for some reason we managed to transmit 12 megabytes within 1 minute. So either because our servers were faster, or because the mirroring client side was faster. It doesn't really matter much, because these are not long running times. That's the kind of data we collect. So far, we don't have a way to let you look at your data. But I think that is something we have to make sure you can do. The code was delivered, it was debugged, we went through a couple of iterations, then it hasn't been touched. So it seems to work, seems to be stable. If and when we need to change it, we'll tell you. I don't foresee any changes to the interface. It's a reasonably structured interface, and it does have a few emergency exits, like during the authentication cycle, there is a response string that is a JSON object, which means if we decide that you can tell us something else than just abort, we don't have to actually change the formal interface. It's a strictly online feature. You can implement your own client if you want to. If you find a good reason to implement your own, I would very much like to know. Otherwise, you're welcome to use ours. It's not a valid SuperOffice database that you can run an alternative client. And we're running out of time, but we still have some minutes. Multiple apps, one mirror per customer. So far, the solution has been the app host, the partner, keeps track of whether a mirroring cycle is already running, aborts any other. We have one partner who are running the whole thing in Azure. And we have an unsolved problem with them getting 502 bad gateway errors. Sometimes. And the call stack on these errors does not contain any of our code. Never reaches that far, seemingly. We don't know why this is happening, whether there is something to do with the size of the calls or the load on the Azure server or the Azure infrastructure restricting them somehow. We don't yet have the answer. But we do know that there is something there which is different from running on-site. Uninstalling an app is something that is subject of a separate presentation that Jens is having sometime during the day. I think it's Jens, maybe Margrethe. But anyway, we have code on our side that will remove the tracking information from the database when the last mirroring app is uninstalled. But presumably, we should maybe make a call to you saying this app has been uninstalled. On the other hand, you already know that through the ordinary termination dance. So you know that you can deprovision your mirror. Binary object size limits, 7 megabytes. That's because I don't want to make a chunking transfer protocol for big objects. Presumably, we can run into the same problem if the EJ message clubs become too large. That hasn't happened yet. And that includes one of the customers that's using mirroring has a very large volume of service tickets. So far it seems to be holding up.
I think we're capping on a megabyte actually.
You're capping on a megabyte.
Yeah.
So in that case, there's no problem. The messages will never become so large that they break this transfer. I was thinking, is there interest in making it possible for your app to reply, for instance, to an authentication call or somewhere in the setup say, I'm not interested in this and this and this table that you would otherwise replicate. I'm only interested in sales, sale history, person, contact, not much more. Perhaps there's a business case for that. Okay, all the other tables maybe are not so big, but you don't want the hassle and you don't want to host them. If there is interest in that, tell me afterwards. Error reporting. Right now, if there is a crash, an email gets generated automatically and it's sent to the technical contact with the CC to Margrethe and it goes into various logs. That is how we have been handling it. It seems to work, but again, I would welcome your opinions on how to handle this. Because we are now living in an ecosystem, we are sharing an ecosystem, and when something blows up, we have a collective responsibility towards the customer. And if you detect that something is blowing up in your code, fine. But it might be that I'm the one who's detecting it because the call stacks and traces are being transferred back to us, and then we are receiving a crash, and we are doing something with it. Testing and debugging might be a problem because our code actually validates all the keys, which means you cannot simulate calls. You can't make a call which is properly signed with our private key because you don't have the private key. And the client code that we give you is not going to accept something that isn't properly signed. Again, no one has complained. So whatever they have done, they've found a solution. And I think that much of the reason for that is that the code that actually gets called from online is code that already is debugged. So the only code that you put in are the hooks. And if your hook code merely leaves marks saying something happened, this needs to be done, then there's actually not much to test and debug. And your code that actually does interesting stuff is run from your own background processes or triggers. You can do that however you want. But again, if there are thoughts on this, once you get up to speed, I'll be happy to know. Mirroring is offered in our development environment in SOD, so that you can set up a test application there and get started with mirroring quite easily. And it's only when you're going to the production phase that Watchcom will come and audit you. So that's it from me. Well, in that case, we're done. There's 1 minute left.